boreal forests of Sweden, a team of scientists has stumbled upon a secret, a really big one, hidden right under our feet. And honestly, this discovery could completely change how we think about forests and their role in fighting climate change.
Think about it. When you picture a forest, what do you see? You see trees, right? These giant woody pillars reaching for the sky, storing carbon. But what if that's not the whole story? What if the most powerful climate weapon a forest has isn't the part we can see at all?
All right, so here's what we've always known. The planet's northern forests, that huge green belt of spruce and pine, are absolutely critical. They're like giant carbon vaults for the planet. We've always understood they store a ton of carbon in the trees, and yeah, in the soil too. But it turns out we didn't know the half of it. And that brings us to this incredible investigation. A team of researchers from Lund University in Sweden and Stanford over in the US got together. They had this hunch that the official numbers just weren't adding up, so they kicked off what you could call the Great Carbon Hunt across all of Sweden.
And when I say they were thorough, I mean they were really thorough. This wasn't just a quick look at some satellite photos. Over 3 years, they mapped out every single old-growth, untouched forest left in the country. Then they actually went out, boots on the ground, to more than 200 different spots to measure the carbon firsthand. They took all that new data and mixed it with decades of old national records to build the most detailed picture of forest carbon that anyone had ever seen for this region.
So, after all that work, what did they find? Well, this is where the story takes a turn. They uncovered something genuinely shocking, a huge, overlooked gap in our understanding.
Okay, just look at this chart. This is the core of their discovery, and the difference is, well, it's staggering. On the left, that's the carbon you find in a natural primary forest. On the right, that's what's in the managed, logged forests that usually replace them. That gap between them is just massive.
So let's put a number on it. 72%. The study found that these old primary forests store a whopping 72% more carbon than the managed forests. And get this, that number already accounts for the carbon that gets stored in wood products like lumber and paper. So even after you build houses with the wood, the original forest was still holding way, way more carbon.
So you've got to ask, where is all this missing carbon? Well, according to Rob Jackson, one of the researchers, the biggest surprise wasn't in the trees, it was in the soil. He called the amount of carbon being lost from the soil because of industrial forestry persistent and shocking.
And this is the part that really blows my mind. In these ancient, untouched forests, almost 2/3, 64% of the carbon isn't even in the trees. It's locked away underground right in the soil. The living trees we see, the things we think of as the forest, they only hold about 30%.
And this quote from the lead author, Didac Pasquale, just drives it home. He said that the soil alone in an old-growth forest holds more carbon than everything in a managed forest. The trees, the dead wood, the soil, all of it combined. Just let that sink in for a second. The dirt is more powerful than the entire replacement forest.
Now, this is bigger than just Sweden. This points to a huge potential blind spot for the entire globe in how we value forests for the climate. So the big question is, why? Why have we been missing this for so long?
I mean, just look at the potential here. If Sweden's managed forests could be restored back to their natural old-growth state, they could store an extra 8 billion tons of carbon dioxide.
8 billion tons is a number so big, it's hard to even imagine. So let's put it this way. That's about the same amount as all of the fossil fuel pollution Sweden has produced for the last 200 years. The entire country's industrial history.
Wow. So if this is happening, why haven't we seen it from space? Well, it's pretty clever, actually. When a tropical rainforest gets cut down for, say, a palm oil farm, the change is dramatic. It's easy for a satellite to spot. But up north, the old-growth forest and the managed tree plantation that replaces it are often the same kind of trees, pine, spruce. So from way up high, they look almost identical. And here's the really alarming part. While we weren't looking, these incredible carbon vaults have been disappearing at a shocking speed. For a while there, Sweden was losing its unprotected old-growth forests at a rate of 1.4% every year. To give you some context, that is 6 times faster than the current rate primary forests are being lost in the Brazilian Amazon. Now here's why this is so critical for climate policy. A lot of our global climate models are counting on managed forests for things like bioenergy. But if those forests store less than half the carbon of the natural ones they replaced, then we might be seriously overestimating their climate benefits. We're getting the math wrong.
So,
this isn't just some interesting finding. It's really the beginning of a whole new chapter in climate science. It feels like this discovery has thrown open the doors to a room full of new questions about the secret life happening in forest soil.
And scientists are now scrambling to figure it all out. Like, what is it about industrial forestry, the heavy plowing, the digging of drainage ditches that causes so much carbon to just disappear from the soil? And what about the fungi, that amazing underground network? Could we maybe even transplant microbes from old soil to new soil to speed up restoration? And of course, the billion-dollar question, does this apply to the other huge boreal forests in places like Canada and Russia too?
So the next mission is pretty clear. We need to go microscopic. We've got to understand the unique community of fungi and bacteria that makes these old-growth soils so incredibly powerful. It seems the secret ingredient is alive. And that leaves us with this final, really powerful thought. For so long, we've been looking up at the trees, but now we know the real magic, the real power, might be in the earth right beneath them. So the ultimate question is, could unlocking the secrets of this ancient soil give us the blueprint we need to help restore our planet's future?